Okay, so good morning. Today we will discuss the probability theory. Okay, and in the next class we will discuss then probability distributions because both are related. Okay, so in probability theory we discuss what is probability. Okay, what its meaning, the different types of you can say definitions of probability. One is the classical definition. Okay, other is the you can say the modern or you can say this statistical definition. Okay, and then we have the basic laws of probability, addition law, multiplication law, what is the independent event, what is dependent event, what is the mutually exclusive events. Okay, and then we have the Bayes theorem, and finally we have something, if we have the time, then the random variable, what are the discrete random variable, what is continuous random variable. Okay, and how you can use these variables. Okay, and what is their meanings, because these are the basics for your probability distribution. Okay, so probability, I hope already you have gone through some sessions. So what is the probability? So probability is basically the chance. Okay, you can calculate mathematically the chance of happening some event. Okay, so what are the chances that this event would happen? Okay, so when we ask you what is the chance that there would be rain or not today, so you just use your you can say your descriptive approach or your wisdom. You use your wisdom or your experience. Okay, according to weather, by looking the weather, whether it's clouds or not. Okay, or that what kind of air you have, so you can predict. Okay, ki whether there would be air, rain or not today, but this prediction may or may not be true. Okay, and your prediction may be different from her. She may predict there may be chances of 50%. You may predict no, there is a 80% chance, because you are using only your experience and you are not using any mathematics. Okay, no, not any rule you can say. So if you want to make sure no, everyone's prediction should be same, then you have to use the probability rules. Okay, so if you know the probability, if you know the mathematics behind that, then you can find the exact probability or standard probability or mathematical probability you can say, and which would be same for all. Anyone if estimate using that formula, it would be always the same value. Okay, so this is the basically need you can say for probability, and now we have basic terminology in probability like deterministic experiment. So deterministic experiment, or what is an experiment? Experiment can be anything. Suppose if you roll a die, okay, I hope everyone knows dice which have the 6 faces, 1, 2, 3, 4, 5, 6. So if you roll a die, this is an experiment. Okay, so the deterministic experiments are those in which we have fixed input. Okay, and action, you can say your yields are जो output है that are also fixed. Okay, so if you do experiment, what you obtain, you always know what you obtain: 1, 2, 3, 4, 5, 6. Either of these value, either of one. Okay, out of 6 you may get any number. Okay, so they are kind of you can say uh, deterministic experiment, or somehow you can also say they are random. Random means uh, although we know the number of outcomes, but I don't know which outcome or which number I would obtain. Okay, so I can obtain anything: 1, 2, 3, 4, 5, 6. So here basically if I say x is my random variable, now what should I tell? What should be the x? X be the number on die. Okay, so let x be the number on die. So number on die can be anything up to 1 to 6. Similarly, if you toss a coin, then x, suppose my x is, there would be head. Okay, head on the coin, or you can say tail. So x can be head or tail, and you may have to find the probability ki what is the chance that you, when you toss a coin, you get head. Okay, or what is the chance you get tail. Similarly, if you toss two coins, so what are the possible outcomes? The possible outcomes are both head, both tail, one head, one tail. Okay. So there can be four possibilities: head, head, tail, 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 head, and head, tail. Because though two coins, so on one you may have head, other on tail, or vice versa. Similarly, if you have three coins, if you toss three coins, there can be eight possibilities. If you toss 10 coins, how much outcomes are possible? 2 raised to power 10. So this much outcomes possible, 2 raised to power 10. If you toss 10 coins simultaneously, there can be many outcomes. But suppose now what is the random variable? I can have, or I can make any event my random variable. I can say ki the number of heads would be my random variable. If I toss suppose 10 coins simultaneously, so how many heads you can obtain? You can obtain 0 head. If you toss 10 coins, all may be the tail. You may obtain 0 head, you may obtain 1 head, you may obtain 2, 3, 4, 5, 6, or you up to 10. Okay. So my random variable can be the number of head obtained, which can take value from 0 to 10. Similarly, if I say my random variable is I should get tail, not head. Again, tail would take values from 0 to 10. Similarly, if you have another experiment, suppose the experiment can be if you roll two dice instead of one. If I roll two die, and my random variable is the sum of two numbers. Sum of two numbers should be 5. Okay. So sum of two numbers would be 5. So what values can be possible on two dice? So that the sum would be 5. 1 4 or 4 1, 2 3 and 3 2. So only 4 values are possible, which supports this number on die would be 5. So total, you know, total possibilities are 36 possibilities. When you roll two dice, there can be 36 possibilities. Okay, 1 1 1 2 1 3 1 6, and then first die pe 2 aa gaya, and then so on 1 to 6. So you can make a matrix. Similarly, if you roll 3 dice, how many possibilities total? There can be 6 raised to power 3. Yani 216 possibilities. Now, if I say getting the number less than 10, this is my success. So that means the sum on the 3 die should be less than 10. So it can be 1 1 1. It can be 1 2 1 1 1 2. There's are many, you can say, possibilities still. Okay. So you can calculate basically the probability corresponding to any event. Okay. If you know the total outcomes, if you know the how many outcomes are favorable to that event. So probability is very simple. If you have this type of situation, okay, where you have some assumptions, you can say, like in the basic definition, this is the classical definition of probability basically. Okay, which says कि if a random experiment can result in n mutually exclusive, exhaustive and equally likely outcomes. Okay, yani if you do an experiment like I roll a die, so there are 6 possibilities. Okay, so we have n mutually exclusive. These all 6 possibilities, like obtaining 1 2 3 4 5 6, these are mutually exclusive. Mutually exclusive means happening of one does not, you can say, uh, sorry, happening of one would rule out the happening of others. यानी अगर आपका 1 आ गया तो 2 3 4 5 6 नहीं आ सकता. डाई में एक ही आएगा ना, या तो 1 आएगा या 2 आएगा या 3 या 4 या 5 या 6. द टू इवेंट्स कैन नॉट अकर साइड बाय साइड. ऐसा नहीं है कि यू कैन हैव 1 and 3 साइमल्टेनियसली. So mutually exclusive means If one occurs, then it would rule out the occurrence of all other events. Okay. If I have to select one student from this class, only one, then all of you are selection of all of you are mutually exclusive. या तो आपका होगा या आपका होगा या आपका या आपका या आपका या उनका, सबका तो दो का तो नहीं हो सकता ना. So then I can say the all of you are selection of all of you are mutually exclusive. Okay. Suppose I draw a card from the pack of 52 cards. So this card would be, if I say this card would be red color. Okay. So in a pack of 52 cards, there are 26 red cards. There are two red colors or two black. Okay. And total card we have 52. So now these red color card can be any of the 26 cards. So total favorable cases which favors to red card is 26 and total possibilities are 52, because your card can be anything, it can be black also. Okay, so favorable case kitne ho gaye 26 and total 52. So you can find the probability of obtaining a red card is 1 by 2, because m upon n, m is the favorable which support to that event and n is the total mutually exclusive possibilities cases, or you can say. So mutually exclusive, then equally likely होना चाहिए इसमें. All the events should be equally likely. When you do that experiment, yes, when you draw a card out of 52, that means all 52 cards have equal chance to be selected. As I said, if I have to select one student from you, so all of you have equal chance. If all of you have equal chance, then you can say you can use this classical definition. बट इफ यू डोंट हैव इक्वल चांस, मान लीजिए आपके ज्यादा चांस है आपके कम है, तो वो इक्वली लाइकली इवेंट्स नहीं हुई. दीज आर नॉट इक्वली लाइकली इवेंट्स. ओके, सो इक्वली लाइकली होना चाहिए, म्यूचुअली होना चाहिए. ओके, एग्जॉस्टिव मीन्स द ऑल द टोटल पॉसिबिलिटीज इन दैट एक्सपेरिमेंट. जैसे कार्ड का केस अगर हम एग्जांपल लेते हैं, टोटल पॉसिबल केस कितने हैं 52. इफ यू रोल ए डाई, टोटल पॉसिबिलिटीज आर 6 ओनली. Okay, so all the possibilities you should explore here. So this is the classical definition and these are the assumptions that there should not be infinite number of, you can say, possibilities. If your n is infinite, then this definition fails. Okay, मान लीजिए आपकी population है, I have to draw a student from the entire India, kind of infinite. N is very very large. Basically, theoretically we did not have the infinite value. That means n is very very large, you can say. Okay, and equally likely, sometimes it is very difficult to have the equally likely cases. Okay, so then again this definition fails. So this definition, you can say, classical definition of probability applicable only in some particular cases only, not always. Okay, like rolling of a die, tossing of coins, okay, drawing a card. In this you can apply this definition. So these are simple examples which I hope you already done, so I would not go in these. So you can see the drawbacks of this, ki when outcomes of the random experiments are not equally likely. Okay, and equally likely, in terms of probability, the term equally likely is used in defining basically probability. And when the total number of elementary events in the sample space is infinite, as both the cases I already discussed with you, infinite अगर होगा और equally likely अगर नहीं होगा, then you have the problem with the definition. So therefore we have the another definition of probability, which is statistical, or you can say empirical definition of probability. And also this is also called as relative frequency approach. Okay, relative frequency probability भी कह सकते हो आप इसको. So if an event A occurs n times in m repetitive of a random experiment, यानी आपने एक एक्सपेरिमेंट परफॉर्म किया 100 टाइम्स, उस 100 में से मान लीजिए जो आपकी फेवरेबल इवेंट है जिसको आप एक्सपेरिमेंट करना चाह रहे थे वो सपोज ये 20 टाइम्स आई, so then you can find the probability of that event is 20 by 100 यानी 0.2. okay, so if you do experiment, जैसे मैंने कहा if you roll a die okay, so what is the probability of getting one? If you roll a die, what is the probability of getting one? 1 by 6. Why? Because you know the total possibilities are 6. 1, 2, 3, 4, 5, 6. All are equally likely and favorable to one, only one. If I say what is the probability of getting even number? क्यों? क्योंकि even number को favorable करने वाली कौन सी events है? 1, 3 and 2, 4, 6. Total favorable case 3 हो गए. Total divide by 6. Okay, तो 1 by 2 आ गया. But how would you make sure that die is unbiased? ऐसा भी तो सकता आपने डाई को फेंका और वो थोड़ी अनबाइज्ड है and there are not equal chance of getting 1, 2, 3, 4 or 5, 6. अभी तो आप क्या assume कर रहे हो? You are assuming that probability of 1, probability of 2, probability of getting 3 or 4, 5, 6 all are equal, which is 1 by 6. सबकी probability same है. 1 की भी 1 by 6 है आने की, 2 की भी 1 by 6 है, 3 की भी 1 by 6 है and so on. But हो सकता है ऐसा ना हो, हमें नहीं पता. So what you do? You actually do the experiment. आपने उस डाई को 100 बाई थ्रो किया, ठीक है, और आपने देखा 100 में से 1 कितनी बार आया? आपने देखा 1 आया 50 टाइम्स मान लीजिए, 2 आया 10 टाइम्स, 3 आया 20 टाइम्स एंड सो ऑन 4, 5, 6 टोटल 100 होगा. ओके, सो यू कैन नोट द फ्रीक्वेंसी कि 1 occurring 50 times, 2 occurring 10 times, 3 occurring 20 times, 4 occurring this much, total is 100. So now you can say your die is unbiased, but it is not biased, it is not unbiased basically, it is biased. Ideally what should happen? All the numbers should be same, okay, but it may not be the same. Okay, this is the die example. You can use some other example also. Okay, if you suppose go from your office to home or home to office, so how many times you have been challaned basically? Okay, suppose you always cross the red lights and in a total of 365 days in a year, okay, so suppose you challaned only 2 times, so you can find the probability of being challaned if you cross the red light always. Okay, it is not necessary that you would always got caught. Okay, so how would you find that probability? You know, total number of you can say experiment you perform 365 days in a year. Suppose always you go 365 days is the total number of you can say experiment which you perform, and how many times you caught? Only 2 times. So 2 by 365. So that is the probability कि you being challaned. Okay. So this way, this is the relative approach basically or statistical approach. कि if you do experiment many times, so then you can calculate the probability. Okay. And this is more authenticate, more you can say useful, and you can find probability for any event. Just perform that event, or if you have data for that event. कि ये मान लीजिए सेल्स है, सेल्स ऑफ ए कंपनी. ओके, सो आपको पता है इफ यू हैव 1 ईयर डेटा, पास्ट 1 ईयर डेटा, ओके, सो यू कैन फाइंड, मान लीजिए आज आपकी सेल 100 यूनिट्स हुई, कल आपकी 150 हुई थी, उससे पहले आपकी 120 हुई, कभी आपकी 50 हुई, so you can find sales of the entire 1 year. Okay, so you can find a frequency distribution कि कंपनी की सेल 0 से 50 10 days, ओके। 50 to 100 मान लीजिए हुई आपकी 100 days, 100 to 150 हुई मान लीजिए 150 days. So you make a frequency distribution and using that you can find the, you can say, probability for different cells कि 0 से 50 की cells की क्या probability है, तो that frequency divided by total frequency. तो you can find, this is the relative approach, okay, relative frequency जिसे हम बोलते हैं, you must have studied in the unit 1, okay, relative frequency, how you can calculate frequency divided by total, so that gives you the basically probability. So if you have data of something, you can find the respective probability. If you have the frequencies, you can find the probabilities basically. So that is the statistical approach of finding the probabilities, okay. And obviously if you repeat this experiment infinitely, theoretically अगर हम कहें, if you repeat the experiment infinitely, then your numbers becomes more accurate, your probability becomes more accurate. Like if you roll a die, okay, आपने कहा मैंने सिर्फ 10 बार एक्सपेरिमेंट करा, तो 1 या 12 टाइम्स करा मान लीजिए आपने, तो 1 आपका मान लीजिए 3 टाइम्स आ गया, तो उसकी प्रोबेबिलिटी क्या हुई 3/12 यानी 1/4. आप कहोगे अकरिंग ऑफ 1 इज 1/4, बट आइडियली कितना होना चाहिए 1/6, you know. So this number, if you only experiment this particular rolling of die experiment only 12 times, then you may not get the your desired probabilities, okay. You have to repeat this experiment at least 1000 times, then you get the probability of 1 would be around 1/6, probability of 2 would be 1/6, 3 would be 1/6. जब आप रिपीटेशन बार बार बहुत बार करोगे तभी तो आपको वो नंबर आएगा, अदरवाइज आपने एक बार ही करा मान लीजिए, इफ यू रोल ए डाई, तो क्या आएगा, या तो 1 आएगा या 2 या 3 या 4 5 6, आप कहोगे तो 100 टाइम्स 100% प्रोबेबिलिटी हो गई, ओके. मान लीजिए 1 आ गया आपका, तो यू से सर 1 आने की 100% है, बाकी की 0 है, यही मीनिंग होगा ना. इफ आई डू ओनली दैट एक्सपेरिमेंट ओनली 1 टाइम, you roll the die and you get 1, तो you would say, अगर आप मान लीजिए उसको रिपीट नहीं करें तो आपकी इंटरप्रिटेशन क्या होगी कि सर 1 की 100% चांस है एंड बाकी 2 3 4 5 के 0% चांस है. अगर आप वही एक्सपेरिमेंट 2 बार करते हो, मान लीजिए एक बार 1 आया, दूसरी बार मान लीजिए 5 आ गया, तो आप कहोगे सर 1 के आने के 50% है और 5 के आने के भी 50% है, अब बाकी सबके 0% है. एंड इफ यू डू दैट एक्सपेरिमेंट 1000 टाइम्स, तब आप कहोगे सर 1 के आने के भी अराउंड 1/6 चांस है, 2 के भी 1/6 है, 3 के भी 1/6 है. तो एज यू कीप ऑन इंक्रीजिंग योर सैंपल साइज, योर रिपीटेशन, तो यू गेट द एग्जैक्ट प्रोबेबिलिटीज बेसिकली, ओके. So that is the classical definition. This is more accurate and more useful, you can say, okay. And you already know probability is always 0 to 1, okay, lies between 0 to 1. 0 means impossible, 1 means 100% certain event. And we have some basic rules already, you know this, and now we will come to the main thing. We can discuss this one first. An urn contains 6 white, 4 red and 9 green balls, okay. If one ball is drawn at random, find the probability that it could be white. It is white. So these types of questions are, you should be practice of these questions, because these are asked, okay, especially for the Bayes theorem, okay. So इसमें क्या है, we have a bag which has the total 19 balls, okay, 4 plus 6 plus 4 plus 9, total 19 balls, different colors, 3 different colors, and you don't want ball. So what would be the chance that it would be white, okay. So these are certain, you can say, outputs here. You already know you have 3 types of balls here, and the favorable cases which support to white are 6 white balls. So 6 divided by the total, okay, so 6/19. or you can find using combination also 6C1 like divided by 90C1. C is the combination basically. How you can select, suppose I have to draw two white balls, okay, without replacement. Two white balls. What is the probability of getting two white balls? So how would you calculate 6C2? Because two white balls can occur in how many ways? Because you have total 6 in the bag. So you can, when you draw the two balls, एक आपने निकाली, second, so there can be 6C2 means 6 into 5 divided by 2, यानी total 15 ways. In 15 ways you can select two balls out of 6. So these are favorable cases, 15, and total would be 19C2. Okay, if you have to draw two balls instead of one, two white balls instead of one, then you have to find 6C2 divided by 19C2. Okay, it is not green, so again 10 by 19, it's very simple. Next is the red or green. एक ही बॉल आपने निकालनी है and it would be either red or green. Now green की क्या possibilities है? Total we have 9 green और red है वो 4. तो whenever we have or word in probability, or जिसे बोलते हैं ना, what is the chance of getting 1 or 2? If you roll a die, what is the chance of getting 1 or 2? या तो 1 या 2. You have to add the probability. Always remember, add. Okay, whenever you have the or in English, not in Hindi, okay, वो end हो जाएगा फिर. तो मैंने I say getting 1 or 2. तो probability of 1 plus probability of 2. This is addition law basically. क्योंकि आपको दोनों के चांस कंसिडर करने पड़ेंगे ना. तो 1 के भी 1/6 है, 2 का भी 1/6, यानी 2/6 1/3 हो जाएगा. And here in this case you have to add the both chances red as well as green. Okay, तो टोटल रेड और ग्रीन मिला के 13 बॉल्स होती हैं, तो 13 डिवाइड बाई 90. सिमिलरली ये एक क्वेश्चन है, प्रोबेबिलिटी ऑफ गेटिंग 53 संडे इन ए रैंडमली सिलेक्टेड लीप ईयर. लीप ईयर मीन्स यू हैव 366 days. Okay, and in each year you know there would be 52 weeks. 52 वीक्स सभी में होंगे बिकॉज 52 इंटू 7 कितना हो गया? 52 इंटू 7 इज 364 days. तो 52 संडेज और मंडेज और ट्यूसडे ये तो सभी में ही होंगे ना. इन ईच ईयर यू हैव 52 वीक्स, सो 52 संडे वुड ऑलवेज, मतलब दिस इज सर्टेन. नाउ व्हाट इज नॉट सर्टेन? द 2 days. 364 days आपके सर्टेन हो गए, where we have 52, you can say Sundays. Now you left with only 2 days. These 2 days can be anything, but they would be on continuation. ये क्या क्या पॉसिबिलिटीज है? पहला डे अगर मंडे है तो दूसरा क्या होगा? ट्यूसडे. ये पहला केस. दूसरा केस क्या हो सकता है? ट्यूसडे वेडनेसडे, वेडनेसडे थर्सडे, थर्सडे फ्राइडे, फ्राइडे सैटरडे, सैटरडे संडे, संडे मंडे. So these are the, you can say, cases which are possible, total 7. कि these 2 days can be anything. So these are total possible cases. अब हमें क्या चाहिए? संडे. I want कि my year, leap year would contain 53 संडे. 52 तो है ही, एक और आ जाए. अब एक किस में आ जाएगा? फर्स्ट वाले केस में आ रहा है और एक आ रहा है आपका लास्ट वाले केस में. तो टोटल फेवरेबल केस कितने हैं? 2 out of 7. तो 2/7 is my chance that a leap year would have 53 Sunday. है जी? 7 is the total favorable cases जो मैंने यहाँ पे लिखे हुए हैं. Okay, next is the conditional probability. देखिए कंडीशनल प्रोबेबिलिटी आपका क्या होता है? व्हेन द टू इवेंट्स आर डिपेंडेंट बेसिकली. इंडिपेंडेंट क्या होता है? व्हाट इज द इंडिपेंडेंट इवेंट्स? इफ द अकरेंस ऑफ वन डज नॉट यू कैन से इम्पैक्ट द अकरेंस ऑफ टू अदर इवेंट. ओके, दो इवेंट हो रही है, आपस में कोई रिलेशन नहीं है बेसिकली, बोथ आर इंडिपेंडेंट. ओके, if something is happening to you, it does not impact you basically, that is independent. But if it impact happening of one event would impact other, then they are dependent. Okay, like if you roll a die, getting 1 or getting 3, okay, occurrence of 1 or 3, they both are independent. एक आएगा या 3 आएगा, उससे कोई रिलेशन थोड़ी है आपस में. बट सिमिलरली इफ यू ड्रॉ ए कार्ड, एक कार्ड निकालते हो आप, मैं कहता हूं ये रेड कलर होगा, एक इवेंट है रेड, ठीक है. दूसरी इवेंट क्या है कि इट वुड बी किंग. अब वन इवेंट इज कि द कार्ड वुड बी रेड एंड अदर इज द इट वुड बी किंग. सो वेदर द टू इवेंट्स आर इंडिपेंडेंट? नो, बिकॉज रेड कार्ड कैन बी किंग. ओके, so both events are not independent, red and king. King can be red also, so then they are dependent event, and whenever you dependent, then you have to know what is the conditional probability basically. So conditional probability क्या, probability of occurrence of any event may be influenced by the information about the occurrence of an event which is already occurred. Okay, तो अगर मुझे पहले से पता है, मेरे को निकालनी है व्हाट इज द प्रोबेबिलिटी कि दिस कार्ड वुड बी किंग, एंड आई हैव बीन गिवन इंफॉर्मेशन दैट द कार्ड इज ऑलरेडी रेड. अगर मुझे पहले से पता है ये रेड है, तो वो उसकी प्रोबेबिलिटी को इम्पैक्ट कर देगा, किंग की प्रोबेबिलिटी को. अगर मुझे पहले नहीं पता कि वो रेड है, तो प्रोबेबिलिटी कुछ और होगी. ओके, इफ यू हैव सम प्रायर इंफॉर्मेशन, okay, then you need to use the conditional probability formula. For example, इन्होंने इसका लिया बॉल्स का. Let us consider a bag contains 100 balls and out of which 60 are red. Okay, 60 क्या आपके red balls है, and 2 balls are selected randomly. Randomly means all the balls have equal chance. Okay, सबको मौका मिल रहा है इक्वल, ये नहीं है किसी को कम किसी को ज्यादा. All the balls have equal chance to be selected. So 2 balls are selected randomly with replacement and then without replacement. दोनों एग्जाम्पल हमारे पास. Okay, so let we say A represents the first ball is red and B represents the second ball is red. There are two events, you can say A and B. Now when you do that experiment, when you draw the two balls, okay, and I will have to find the probability that both would be red. इसके क्या चांस है कि both would be red, यानी पहली भी रेड हो और दूसरी भी रेड हो. इफ यू डू दिस एक्सपेरिमेंट विद रिप्लेसमेंट का मतलब क्या है, मैंने एक बॉल निकाली, उसका कलर देखा, फिर उसको वापस रख दिया. अगेन आई ड्रॉ द अनदर बॉल, सेकेंड टाइम फिर से देखा. अब मैं ये कह रहा हूं जो दोनों बॉल्स निकली देन बोथ वुड बी रेड, इसकी क्या चांस है. तो जो फर्स्ट केस है, ओके, पहले फर्स्ट टाइम व्हेन यू ड्रॉ द बॉल 60 रेड है ना, तो फेवरेबल केस कितने हो गए, 60 डिवाइड बाई 100, 3/5. व्हेन यू पुट अगेन एंड अगेन ड्रॉ, तो अगेन द चांस वुड रिमेन सेम, 3/5 ही रहेगा ना. सो द बोथ बॉल्स वुड बी रेड. ओके, देयर टू इवेंट, ए बॉल एट फर्स्ट ड्रॉ में रेड है, बी क्या है सेकंड ड्रॉ में भी रेड है. तो व्हेन एवर यू हैव एंड वर्ड ए एंड बी, ए एंड बी का मतलब पहले में भी रेड हो एंड सेकंड में भी रेड हो, और नहीं है, तो यहाँ मल्टीप्लाई करोगे तो 3/5 मल्टीप्लाइड बाई 355 कितना हो जाएगा, 9/25. तो दिस इज द प्रोबेबिलिटी कि बोथ बॉल्स वुड बी रेड. कितनी प्रोबेबिलिटी है, 9/25 विद विद रिप्लेसमेंट। विद रिप्लेसमेंट पे क्या है, बोथ इवेंट्स आर इंडिपेंडेंट। यहाँ पे कंडीशनल का या कोई लॉजिक नहीं है, क्योंकि दोनों में कोई डिपेंडेंस नहीं रहा। बट इफ यू डू विदाउट रिप्लेसमेंट, आपने एक निकाली, अब दूसरी निकाल रहे हो बोल, जब दूसरे निकाल रहे हो तो प्रोबेबिलिटी सेम नहीं रहेगी। क्यों? नाउ यू हैव 99 बॉल्स, 100 नहीं रही है वहां, 99 और रेड बॉल्स है, उसका भी आपको नहीं पता। अब वो पहले ड्रॉ में अगर वो रेड चली गई है तो 59 रेड है, अगर पहले ड्रॉ में वो रेड नहीं थी तो 60 रेड है। तो यू हैव कंसिडर, so basically now the probability of second red ball would depend upon first। पहले पे डिपेंड करेगी ना, अगर पहले रेड है तो प्रोबेबिलिटी कुछ और होगी, तब 59 बाई 99 हो जाएगी, और अगर पहले में रेड नहीं है तो 60 बाई 99 हो जाएगी। So therefore this example shows you the use of conditional probability. You must use here conditional probability instead of you can say simple probability. Okay, so here this is the proper definition. You can see conditional probability, a given b, a ये स्लैश b का मतलब क्या है, a given b, और यू कैन से प्रोबेबिलिटी ऑफ कंडीशनल प्रोबेबिलिटी ऑफ a given b। a को हम क्या बोलेंगे, कंडीशनल प्रोबेबिलिटी ऑफ a given b, और यू कैन से b हैज ऑलरेडी अकर्ड, हैपेंड और अकर्ड। ओके, सो कंडीशनल प्रोबेबिलिटी ऑफ a given b और b given a। ओके, तो दोनों का थोड़ा सा फॉर्मूला चेंज होता है। जैसे a गिवन b है तो नीचे डिनोमिनेटर में पी ए आएगा, और यहाँ पे दोनों का इंटरसेक्शन या मल्टीप्लिकेशन आ जाता है, पी ए इंटू बी। इंटरसेक्शन या मल्टीप्लिकेशन एक ही बात है, यूनियन और प्लस एक बात है, ठीक है। इंटरसेक्शन का मतलब मल्टीप्लिकेशन, यूनियन का मतलब प्लस। बट इसमें यह ध्यान रखना, प्रोवाइडेड जो डिनोमिनेटर में जो भी प्रोबेबिलिटी आ रही है इट शुड नॉट बी जीरो, otherwise it is undefined हो जाएगी। okay, so this is the conditional probability, and using conditional probability you can find the multiplicative law also, theorem of multiplication जो होती है आपकी। तो you can see a intersection b equal to क्या होगा, p a into p b if both are independent, but dependent है तो क्या होगा, b given a, और you can write p b into p a given b। बट इफ ए एंड बी आर इंडिपेंडेंट तो ये क्या हो जाएगा, सिंपली पी ए इंटू पी बी। अगर डिपेंडेंट है तो ये कंडीशनल प्रोबेबिलिटी के टर्म्स में आएगा, अदरवाइज तो ये आप कैसे भी कह लीजिए, इस फार्मूले को अगर आप बी को नीचे ले जाते हो तो वही सेम फार्मूला कंडीशनल का बन जाएगा। ओके, जो ऊपर लिखा था, इसी को अगर आप पी ए को इधर ले जाओगे आप, तो पी ए इंटू, ओके ये इसमें गलत लिखा हो, ये पी बी है, सॉरी, हाँ ये मिस है, वहां पे पी बी गिवन ए आएगा, तो पी ए इंटू पी बी गिवन ए वुड बी इक्वल टू द मल्टीप्लीकेशन। करेक्ट कर लेना अपने इसमें। ओके, नेक्स्ट वी हैव द बेस थ्योरम। बेस थ्योरम भी इन्हीं के कंसेप्ट पे है, मल्टीप्लिकेशन पे और आपकी कंडीशनल प्रोबेबिलिटी पे, बेसिकली इसी का एक्सटेंडेड फॉर्म है। ओके, बेस थ्योरम आई कैन से हियर, या दिस इज द फार्मूला फॉर द बेस थ्योरम। अगर मैं आपको बताऊं, दिस इज द बेस थ्योरम फार्मूला। अगेन यू कैन फाइंड द कंडीशनल प्रोबेबिलिटी ऑफ एनी इवेंट गिवन दैट, मतलब यू हैव टू फाइंड ई आई गिवन दैट ए हैज ऑलरेडी हैपेंड। तो इसका अगर फार्मूला है, ये आपका होता है ए यूनियन इंटरसेक्शन ई आई अपॉन द पी ए, और पी ए को एक्सटेंडेड फॉर्म में लिखेंगे समीशन पी ई आई इंटू पी ए गिवन ई आई फ्रॉम 1 to n, जितने भी पॉसिबिलिटीज है। तो ये एग्जाम्पल से आपको थोड़ा ज्यादा क्लियर होगा। अगेन यहाँ पे जो पी ई आई है, दीज आर कॉल्ड प्रायर प्रोबेबिलिटी, ओके, और जो पी ए ई आई गिवन ए है, दीज आर पोस्टीरियर प्रोबेबिलिटी। ओके ये तीन चीजें इसमें आपकी. वी हैव टू फाइंड द पोस्टियर प्रोबेबिलिटी. ओके पहले से कुछ इन्फॉर्मेशन आपके पास प्रायर प्रोबेबिलिटी है एंड यू हैव टू फाइंड द पोस्टियर प्रोबेबिलिटी विद द हेल्प ऑफ बेस थ्योरम. Okay, so this is basically Bayes theorem. So if you see one example, yes, this example you can see. This is for the Bayes theorem. A bag contains again 4 white and 5 black balls. Okay, total we have 9 balls in the bag, and in the second bag we have 2 white and 3 black. तो फर्स्ट बैग में हमारे पास 9 balls है, सेकंड में टोटल 5 balls है, ब्लैक एंड वाइट. ओके नाउ ए ball is drawn from the first bag and it is transferred to the second bag. फर्स्ट से आपने सेकंड में ट्रांसफर कर दी. Then a ball is drawn from the second bag and it is found to be white. ठीक है. So what is the probability that the white ball was transferred from first to second bag? Okay. यानी आपको ये गिवन है, एक 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 जो इंफॉर्मेशन है वो इंफॉर्मेशन क्या थी कि आपने एक जो बॉल निकाली सेकंड बैग से वो वाइट थी. आपने क्या किया, एक बॉल फर्स्ट बैग से सेकंड बैग में ट्रांसफर करी, फिर सेकंड बॉल से बॉल निकाली, वो बॉल निकली वाइट. नाउ व्हाट यू हैव टू नीड टू फाइंड, यू हैव टू फाइंड कि जो आपने बॉल ट्रांसफर की थी फर्स्ट से सेकंड में, ओके उस वो वाइट हो उसकी क्या चांसेस है. व्हाट इज द प्रोबेबिलिटी दैट वाइट बॉल वाज ट्रांसफर्ड फ्रॉम फर्स्ट टू सेकंड. ओके so you have some information and you have to find the prior probability basically here. So you have to use the Bayes theorem. So Bayes theorem में आपको क्या है, देखिए अब इसमें दो आपकी इवेंट कह लीजिए E1 और E2, दो बैग्स हैं आपके. ओके और क्योंकि आपको व्हाइट बॉल यहाँ पे कंसिडर कर रहे हो आप, आपको फाइनली व्हाइट बॉल की प्रोबेबिलिटी निकालनी है. तो हियर यू कैन से प्रोबेबिलिटी ऑफ सिलेक्टिंग व्हाइट बॉल फ्रॉम फर्स्ट बैग वो 4/9 है, सेकंड बैग में आपकी 5/9 है. ओके सेकंड में 5/9 होगा तो गलत है. हाँ जी ये इसमें ना थोड़ा सा रिवर्स लिखा हुआ है, कुछ मिस हो रहा है यहाँ पे. ये आपका आएगा 4/9 एंड यहाँ का आएगा 2/5. ओके so you can find all these things and using this you can applying the Bayes theorem you can get the answer. Yeah, there may be some miscorrection here. Okay so you need to do that. We can take this another example. There a company have 3 machine, it manufacture the 3 machine and the 3 machine manufacture 20, 30 and 50% of the total output, and out of these 6, 3 and 2% are defective basically. So a bolt is drawn at random and it is found to be defective. Find the probability that the defective bolt is manufactured by machine 1. Okay so यहाँ पे देखिए ये सही एग्जांपल है. वी हैव 3 मशीन, उनका हमें प्रोडक्शन पता है कि कितना कितना प्रोडक्शन हो रहा है और उनका डिफेक्टिव भी पता है. व्हाट इज द डिफेक्टिव रेट, 6%, 3%, 2%. देन ये बोल्ट आपने लिया रैंडमली एंड इट इज फाउंड टू बी डिफेक्टिव. सो व्हाट इज द प्रोबेबिलिटी दैट इट इज मैन्युफैक्चर्ड बाय द फर्स्ट मशीन. So here you have to represent all these three events A1, A2, A3 that the defective bolts are manufactured by machine 1, 2 और 3. तो 1 के जो चांसेस हैं फर्स्ट मशीन के वो आपका क्योंकि इसका टोटल जो मैन्युफैक्चरिंग है आपकी जो टोटल आउटपुट कितना मैन्युफैक्चर करती है 20%, तो 20/100 यानी 1/5. सेकंड मशीन का जो प्रोबेबिलिटी है दैट इज 0.3 एंड थर्ड की 1/2 है. नाउ इफ यू रिप्रेजेंट ए एज योर you can say even that ball drawn is defective. अब defective from first machine उसके चांस 6% है, defective from second उसके 3% है, defective from third इसके 0.02 है. Now you have to find, you can find the total probability, this PA1 into A given A1. You know all the things and you can find P because this is for the denominator. When you use the Bayes theorem, okay, this is for denominator. So PA आपका 0.031 आ गया. और now you have to find the reverse of this probability that the defective bolt is from the machine first. So A1 given A is the probability of defective and A1 is from the machine 1. तो ये आपने रिवर्स कर दिया. इसमें भी थोड़ा सा ना यहाँ पे क्या बोलते हैं उसको मिस प्रिंट हुआ है ये, ठीक है. ये आपका यहाँ पे जो आएगा A1 नहीं, ठीक है, ये A/A1 है, ठीक है, ये ठीक है. तो ये आपका टोटल 1/5 इंटू 0.06 ये निकाला और टोटल 12/31. तो बेस थ्योरम में बेसिकली एक आता है यू हैव सम प्रोबेबिलिटी एंड यू नीड टू फाइंड द प्रायर प्रोबेबिलिटी. ओके, तो और बेसिकली व्हेन यू टू इवेंट्स आर dependent events, okay, then you have to use the Bayes theorem. So you can practice this. Finally we have the random variables because this is useful for the next chapter, which is the probability distributions. We have the many distributions like binomial, Poisson, exponential, normal, okay, uniform distributions. So before that you must know what is the random variable, what kind of random variables you have. Already I told you what is a random variable. Okay, so a random variable can take any value within its domain. If I select a student out of this class, okay, so then X, if I say what is X, X is any student. So X can be you or you, any one of you. So my domain is only this. X can take values from only from this class. Okay. If I say X is the height of the student, X represents the height of the student. So what is the minimum value of height? So suppose I consider only for this class, though suppose the minimum height is 150 centimeter and maximum is suppose 210 centimeter. So X can take any value between 150 to 210. Okay. Further, X, which is my random variable, it can contain finite value, it can contain infinite value. Further, the random variable can be discrete, can be continuous. Discrete means when it is taking only integer value. Like I am saying ki age. What is the age of the students in this class? Only in year, not in fraction. तो मान लीजिए someone says 20, कोई 21 है, कोई 22, कोई 25. Okay, so X is taking only integer value. If I say height, which may be in fraction, so it can take any value, 165.2, okay, 150.3. So then I say कि X is continuous. Because depending upon discrete and continuous random variable, you have probability distribution. So some probability distribution are discrete, some are continuous. So like binomial and Poisson, they are discrete probability distribution. Normal, uniform, exponential, they are continuous probability distribution because your random variable is continuous. So you should know what is random variable, the different types, discrete random variable, continuous random variable. Your random variable can be, you can say deterministic. Okay, you know your random variables value, you may not your random variables value. Okay, Further, your random variable can contain infinite values, or it can contain finite values or countable values basically. Okay. So we will study more about these random variables and the distributions in further class whenever we have. Okay, and these are the some properties of these random variables. Okay, so you should go through these properties and random variable, and then we have the one is the function, frequency distribution function. Okay, or probability distribution. Then we have the cumulative probability distribution function. So this is basically cumulative probability distribution. Okay, first we have the simple probability distribution, then we have the cumulative. If you add, जैसे आपका frequency distribution था, फिर cumulative. Similarly, you have cumulative probability distribution. So which you can see here, its property. Okay, all these properties for cumulative distributions. And for discrete random variable, we have probability mass function. For continuous random variable, we have probability density function, PDF जिसे हम बोलते हैं. So you should go through all these things. Okay. So if you would have any doubt, you can ask me about this in the next class. And around about probability, if you have any doubt, you can ask me. Okay. If you have anything, otherwise, thank you. Any doubt? Hanji. So next time we will discuss these distributions. Okay, probability distributions, which is you can see in the next chapter. So you can see we have these distributions basically binomial, Poisson, exponential, and normal. All these four distribution, their properties, okay, and what kind of questions you may have. And I would suggest you must go through the question papers, previous year question papers of BBA and BMS, so that you should have some understanding what kind of questions you may be asked. Okay, so thank you.